A very good afternoon and a warm welcome. Thank you for joining in. Planetarium is glad to have your participation in this celebration of 61st anniversary of the first human space flight by a Soviet cosmonaut Yuri Gagarin. On 12th April 1961, Yuri became the first human to orbit the Earth, opening a new chapter of human endeavor in the outer space. This was an important contribution to space science and technology, and also this historic event opened the way for space exploration for the benefit of all humanity. Let's recall this amazing history of human presence in outer space and the remarkable achievements since the first human spaceflight. Today, to share more insight on this magnificent journey, we have with us as a guest Dr. Patralekha Mitra, co-founder and academic head at STEM in Space organization. Dr. Mila had done her BSc in physics from St. Stephen's College, University of Delhi, followed by PhD in astronomy from United States of America. She has worked in diverse fields related to research and outreach in astronomy domain. Her experience also include reputed aerospace companies such as NASA Goddard, NASA Ames, and Stanford Linear Accelerator Center in United States, which has given her the opportunity to build international global experience. She is passionate about dissemination of science specifically through astronomy and earth science to students and public in easy and innovative way through science outreach and communication. She is actively involved in all the science related, specifically astronomy, workshop through her STEM in Space organization. So, Planetarium is really very glad to host you, ma'am, to talk on this magnificent journey of human presence in the outer space. Over to you.
Hello, everyone. Uh, Thank you to Nehru Planetarium for inviting me on this very special occasion. I will really enjoy interacting with all the students who are viewing this, and I'm looking forward to sharing more about the history of how space exploration started. So, with that, let me share.
Meanwhile, ma'am is sharing her screen. I would like to tell all the participants, online participants, you can drop your relative questions and doubt regarding the presentation that and the topic which we are discussing today in the chat box. And soon after the presentation gets over, we'll be taking your doubts. So you are free to ask anything, but it should be related to the presentation that we are talking about. You can drop in the chat box.
So, as Prerna ma'am mentioned, today is a very special day. It's the International Day of Human Spaceflight, and it's a special day not just one, but two historical events that happen that has brought us to where we are today. So let's talk about what is the International Day of Human Spaceflight. It's an annual celebration held on April 12th every year. It's on the anniversary of the first human spaceflight, as you know, that was by Yuri Gagarin of the USSR. So, this is a UN highlighted event, and UN proclaimed this day on 7th April in 2011, which was the 50th anniversary. So, this is also specially commemorated in the Soviet Union as the Cosmonautics Day. As you know, Yuri Gagarin was from USSR and a cosmonaut, and in fact, the Trade Space Center and the training agency are named after him as the Gagarin Space Center. Even in the US, it is celebrated today, especially as Yuri's Night. And many amateur astronomers and many space enthusiasts do programs on this day. Now, we knew all this, but did you know there's another special event that's celebrated today that also happened on April 12th? And that is You've heard about the space shuttles, and I will talk more about them today and what is their contribution. But the first space shuttle, the Columbia, was, and that is called the STS number 1 mission, was also launched on 12th April 1981. So that's exactly 20 years after the historic flight by Yuri Gagarin. So today, let's take the time to find out how all this came into play and what triggered this race for space exploration. In fact, it is called the space race, and that's how it started. The space race, although it sounds exciting, was actually a little dark. It was a competition between the two Cold War. It was at that time it was called the Cold War. It was just after World War II, and it was a competition between USSR or Soviet Union and the United States, and the whole objective was to show which country has developed superior spaceflight capability. And why is that? It was connected to defense, because the concept was that if you have missile based nuclear arms and if you have a way of defending yourself against it, then you are a much superior power. So the need for this uh, space based defense is what led to the need for space flight and uh, getting into space. And as a result of this space race propelled by the Cold War, many things happened that have brought us to all the way of where space exploration is today. So, space race brought in artificial satellites, space probes, human space flights, and ultimately the moon landing. So, I'm going to talk about some of these historical things today. I won't talk so much about modern space exploration. So, let's talk about how all this started and how it came into play. So, remember, this was a competition. So, whatever USSR was doing, US was trying to match, and vice versa. So, this is the first thing that happened in this timeline. And I will talk to you about some of these events further. So, the first thing that happened was in October 4th, 1957, the first space module, which was called the Sputnik, was launched by the USSR. Following that, just a few weeks later, the Sputnik 2 was also launched by USSR, and that carried the first living creature. As you all know about this historical fact, Laika the dog was the first living creature in space. Now the US also started pushing their space exploration. So in 1958, US launched Explorer. And in fact, NASA was formed at that time to as a center that would make the space exploration, research it, get the funding, and see what could be done. So we all know NASA very well now. It formed in 1958. Again, the first human in space was by USSR, that's Yuri Gagarin, in 1961. So everything I'm talking about is really at the end of 50s, going into 60s and early 70s. Then the first American in space was Alan Shepard in 1961, but his was a suborbital flight and it lasted for a very short time. It did not make an orbit. And in 1959-60, the first human made object to hit the moon was also by the USSR and called Luna 2. Then we all know 1969, that was the big moment for US, and that was a big moment for space, in fact, because that was when the first humans landed on the moon, Apollo 11. Further to that, US sent other missions to Mercury, Venus, and Mars. And finally, the first space station was also by USSR called Salyut 1. So this is a timeline. As you can see, they were rapidly developing between late 50s to 1970s. So I'm going to talk a bit further about how these came into being. Okay, so as I said, Sputnik was the first artificial satellite. It was a very small satellite, just the size of a beach ball, and weighed only 83 kilos. and it had four antennas, as you can see. So the objective of these satellites was actually to test what space had, the atmosphere, the cosmic radiation. So these were the first tests of what any uh, space vehicle would have to face. So this Sputnik took about 98 minutes to orbit Earth. It went into low elliptical orbit, and it orbited for 3 weeks, at which time its fuel ran out. So now this was a new thing because this is the first object in space. So this had a lot of political implications, and like I said, at that time it was connected to defense and military. So there were those implications, and of course it's a huge scientific and technical achievement. It marked the start of the space age, and USSR was obviously ahead at this point. In fact, then USSR launched Sputnik 2. This was the second spacecraft that was launched into Earth orbit, and it was just launched a few weeks later. Again, it's a cone shaped object. The interesting thing is that it carried the first living animal called Laika. And of course, as you can tell, it was very experimental. Nobody would knew what would happen to Laika in the space conditions. And that was, of course, the test. It was obviously they were risking Laika's life, but it was to get a handle on what kind of conditions you have in space that would have to be faced by astronauts if they went. And in fact, Laika died on the fourth orbit, but that was due to technical problems, which was an air conditioning malfunction. But still, of course, Laika is a hero because, uh, she was part of the history of how space exploration started. And now coming to Yuri Gagarin. Of course, today's webinar and on the special day today, we are celebrating the contributions of Yuri Gagarin, cosmonaut, because of course now we can talk about him in retrospect and uh, say what he did, but just imagine when he went, he really didn't know anything about what the conditions would be and if he would be able to come back. Okay, so this is in April 12, 1961. Yuri Gagarin became the first human to orbit Earth. The mission was called Vostok 1. He was a Soviet pilot and cosmonaut. His flight lasted 108 minutes. Okay, so I have a short video. So please do tell me, ma'am, if you can hear it. Otherwise, I'll just describe it a little bit.
No sound, ma'am.
You can't hear the sound? Okay. So I'll just describe it a bit and walk through it quickly. So Yuri Gagarin was the son of a carpenter. He was selected with as the first set of cosmonauts, and the so two of them were selected as the final cosmonauts. And in fact, Gagarin was selected to be the first cosmonaut. All of his peers recommended him because he was so at age 27. This was the launch. This is at the launch pad. And of course, he didn't know if he would be able to come back. So, a very famous line he employed is called "Let's go." And now that line is used to start off many missions, the "Let's go." Okay, so here he is in space. This is an animation. Yeah. Now, remember, this was the first mission. There were many problems. During re entry, he faced a lot of problems. So, the descent module had a problem with the cable. So it was shaking very strongly. And just as he entered, it was falling apart. Okay, so what happened is, uh, because at that time you did not have the right way, the right engines to slow down your landing. So he faced a lot of vibrations and almost it fell apart, and he had to use a parachute to land. And even there, he had a problem because the parachute almost landed on the water, in the ocean, although he was meant to land on the ground. And somehow he managed to land. So I'm trying to make the point that this was very long back. Many safety systems were not tested, and there were a lot of risks attached, and yet he did make it back safely. And it's a big thing. That's why he's an international space hero, because he went into all these situations not knowing what he would face. And in fact, there were several problems. Okay, so Yuri Gagarin came from a very middle class household. He was the son of a carpenter, and he, in fact, Russia faced Nazi occupation, and Yuri Gagarin's family was made to live in a small mud hut. So he missed a lot of the formal education in the formative years, but even then he was determined to make it, uh, and he joined the military academy, and that's how he made his way to the astronaut. Uh, he was selected as an astronaut. He was one of six special astronauts who were called the Sochi Six, and they were trained. And he completed his formal education at the same time. And all of his peers said that Yuri Gagarin should be the one to go first, because he was so dedicated and he could think so much, so fast. His reaction time was very fast, and also height wise, for the Vostok 1, they needed somebody who was not too tall, because you had to fit into a small space. So Yuri Gagarin had all these requirements, and he was the first to go. And when he came back, he became a national hero, and he visited many countries. Following his flight, he became the deputy training director of the Cosmonaut Training Center. Did he go on any other missions? He served as the backup crew to the next mission, which was Soyuz 1. Not the next, but soon after. But this ended in a fatal crash, killing his fellow cosmonaut. So now, again, you know that there have been many dangers that these astronauts and cosmonauts have faced. So, because they were fearful that a national hero might be killed, the Soviet officials banned him from future space flights. So, however, it was obviously, these are the kind of people who were used to taking risks. So he started flying in the Air Force, and a MiG-15 training jet he was piloting also crashed, and he did die at a young age in 1968. But he's always remembered as a national hero, and that's how the space race first started with the USSR. Now I'm going to talk a little bit about the US. So, what happened to the US at this point? So, the US was now behind the USSR in the space race. So, let's talk about some major milestones. And, students, you don't have to remember the dates, you just get a broad idea. I just want to lead you through what are the major missions and projects that happened till we reach the modern times. Okay, so US started its space program in 61 also, and they were furiously also racing. And the first missions were called Project Mercury. And as part of Mercury, they did have two astronauts that went to space. And then followed by Project Gemini, then the Apollo missions, and finally the space shuttle era, which of course we are also celebrating today, the first space shuttle. So let's talk a bit about some of these. So Mercury missions was also in the early 60s, These were one man capsules, so they're very small. Only one man could fit in. And this was the first US program to put humans into space. There were 25 flights, six of which carried astronauts. So the first American astronaut, Alan Shepard, flew to space in 1961. He flew to space, but he did not go into orbit. And next was in 1962, John Glenn became the first American to orbit Earth. Then he orbited Earth three times. Now, both Alan Shepard and John Glenn are very famous, and John Glenn has also become a senator recently. From the Mercury mission, it went on to Gemini, which were the two-person capsules. Now, both Mercury and Gemini had the objectives of making the space technology work. So, spacecraft control, how do you rendezvous and dock with another space lab, even extravehicular activity, these were things that were being tested. Now we move on to the Apollo program. So, you all know about the Apollo program. That is a huge achievement for the space program. So, how did it start? In 1961, John F. Kennedy, who was the president then, he gave out a challenge. He committed that the United States would land a person on the moon before the decade was complete. So, that was a big uh, trigger for NASA to furiously work on a program that could take somebody to the moon. So the Apollo program was designed to land humans on the moon and bring them back. So Apollo 11, that was the first successful mission. Apollo had several other successful missions too, five more. So that made it a total of six successful missions to the moon where humans went to the moon and back. So that's Apollo 11, 12, 13, 14, 15, 16, and 17. The last Apollo 17 was in 1972. So 12 people walked on the moon as part of the Apollo program. Okay, so now that the men had gone to the moon and back, now the next challenge was to design a reusable spacecraft. So, what do we mean by reusable? That because there were also budget and financial issues, so NASA was being constrained to be careful about the finances. They also wanted to build a space station. They also wanted to invest in space telescopes eventually. But the first thing was to build reusable spacecraft. And this was called the space shuttles. So the whole concept was to build something that could launch telescopes or other missions and uh, be able to come back. So the NASA space shuttle had five uh, five vehicles in the fleet, and the vehicles are called Columbia, Challenger, Discovery, Atlantis, and Endeavour. Okay, so these were humanity's first reusable spacecraft. So, again, what do we mean by reusable? So each space shuttle had an orbiter launched. So the orbiter launched with two reusable solid rocket boosters. So always you'd see two boosters on the side, and those would actually come back to Earth and be reusable. And there was a disposable external fuel tank, and that part was not reusable. So most of the components would be usable, and that meant that these five shuttle fleet could do many missions and come back and do it again. So they also had a large carrying capacity. Up till now, we've talked of missions that only carried one person, or in the Gemini program, carried two people. And incidentally, that's why Gemini was called Gemini, because Gemini is twins. So they could carry two people. Now, the space shuttle could actually carry up to eight astronauts and up to 23,000 kilograms payload into low Earth orbit. So, this means that you could carry a lot more material, which eventually helped carry prominent telescopes and prominent, even components of the ISS, International Space Station. So, because it's reusable, when the mission was complete, the orbiter would re enter the Earth's atmosphere and land like a glider or actually even like a plane. So, they would land at the Kennedy Space Center or Edwards Air Force Base. So, basically, they could be reused and they really landed. If you've seen the landings, they landed like flights itself. Each vehicle had a 10-year lifespan. So over 30 years, so they didn't all start at the same time. Columbia was the first one, and then the other ones came after a few years. Uh, so over 30 years, 135 missions flew with these space shuttles, and they carried 355 astronauts to space. Okay, so again today we are celebrating not only Yuri Gagarin's historic launch in 1961, but also we are remembering Space Shuttle Columbia. Space Shuttle Columbia was the first space shuttle to launch. Remember, this is humanity's first reusable vehicle. If you see the picture here, you can see the two solid rocket boosters on the sides. Columbia was named after the first ship to navigate the globe and also the command module for Apollo 11, which was again the mission that landed on the moon. That had its command module was also called Columbia. So all of these missions were referred to as Space Transportation System. So STS. So this was a flight STS-1, the first flight. It had only a two-person crew, the commander, John Young, who was a veteran of Gemini and Apollo missions, and the pilot, Bob Crippen. So Columbia flew 28 missions in its lifetime. So, first of all, when the shuttle program started, they were doing smaller things such as repairing things that were in space and deploying satellites and telescopes. But later on, the shuttles themselves started carrying out many more science missions and furthering the concepts of furthering research. Okay, so again, I have a small video that probably won't play. I mean, you won't hear the sound, but I'll just talk you through because these are historical moments. You can see when the video looks so different than it does now. That was the launch of Columbia. Okay, so that's America's first space shuttle, Columbia. It's going into space, and then there will be a separation. As we know, these are the astronauts on board. You look at the spacing they have available, it was much tighter than it's now, but still it was I mean, space shuttle already had a lot more uh, area available for them, and this was the first space launch, so there was a huge media and public presence because it was going to make us the first it was US's first space shuttle launch, and see how it's landing back. It actually lands like a plane itself. So that's it, and it's landing, and it becomes reusable, ready for many more launches. And it was a huge success. The media and the public made were really excited, and it was a lot in the media. There it goes, it lands. Okay. Okay, so I just mentioned space shuttles, but and I told you they started off with repairing telescopes and so on. But over the years, over 30 years, they had huge achievements. So let's talk about some of the achievements. So over 30 years, space shuttles operated over 30 years. They carried astronauts into orbit repeatedly. They also used to dock with the ISS. So, coming back to it, they launched, recovered, and repaired satellites. So, here on the side, you may see it's a very interesting point because, as you may know, when the Hubble Space Telescope was launched, then it had a flaw in it. It had a flaw with the mirror. So, such a huge, expensive space telescope was suddenly found to have a flaw, but a space shuttle was able to carry astronauts who were able to repair it. So, this is in fact a picture of repairing the Hubble Space Telescope, which after that gave us so many years of wonderful data. So, they were able to launch and recover and repair satellites. So, the ISS, the International Space Station, which is the largest structure in space, was built by modules that was carried up in the space shuttles, and they were carried up bit by bit, large pieces one at a time, and they were put together. So this is the way International Space Station was built. So again, space shuttles are responsible for carrying the material or the components of the International Space Station. So ISS, not ISS, sorry, the space shuttles carried many prominent telescopes to low Earth orbit and deployed them. Some of them are ones we know very well. Hubble Space Telescope was deployed by these shuttles, and of course also repaired, not just once but maintained also by astronauts on these space shuttles. Then also ISS components were carried, and the Compton Gamma Ray Observatory. These are all to low Earth orbit. Also to high Earth orbit, there were some deployments, including the Chandra X-ray Observatory. And even deployments to interplanetary missions were carried out, like the Magellan that and Galileo that have been to Mercury and Venus. Okay, unfortunately, as you know, of course, with space exploration, you also have challenges because you don't know all the problems that the technology may face. So, here are some shuttle disasters, as you know about in the past. The
Hello.
first one was in 1986 when the Space Shuttle Challenger broke apart during its launch. Just 73 seconds into its flight, it broke apart, killing all seven crew members aboard. And later on, there was a whole investigation into this, and it was found to be due to a small part called O-rings. So there were faulty O-rings. It was just a small part, but it caused a leakage so that there was this blow up. Now, the crew at that time included the first teacher who was going to go into space, Krista McAuliffe. So this is very sad, but again, all of them are heroes now. Now, the next space disaster, which was quite a few years later, was the space shuttle Columbia, which in 2003 is disintegrated when it was re-entering the atmosphere. And as you know, Kalpana Chawla, our astronaut Kalpana Chawla, was also uh, in that. So what happened then? This was a disintegration as it was entering back into the atmosphere. So there were some technological problems, there were some maintenance problems that were already known, and this was already known as a possible problem, but still the mission had gone ahead. So what happened is pieces of the foam, when a mission enters the atmosphere, it faces a lot of heat, it almost burns up, so it needs a very protective insulative coating. So pieces of that insulative foam broke off and it struck the thermal protection systems, which caused it to explode. So after this, the shuttles were, in each case, they were put under investigation for 2 years when they were not used at all. And even after that, it was really almost the end for the space shuttle program. And they were mostly used to only transport astronauts back and forth to the ISS and back. Okay, so that's the space shuttle, and I hope you've all realized that the space shuttle created a lot of achievements. Again, like I said, it it deployed many of the space telescopes that we know now, sorry, um, it carried people to the ISS and back from the ISS repeatedly. It launched and repaired satellites. And again, just to remind you, Hubble Space Telescope was repaired by astronauts who went up on the space shuttle and did a space walk to repair it. It has space shuttles have also launched uh, major missions into low Earth orbit, high Earth orbit, and also interplanetary missions. So the over 30 years, space shuttles have been a key component of space exploration history, and they will always. We are still getting the benefits of the satellites that are in space and carried by the space shuttles. Okay, so with that, now I'm going to talk about one more modern mission. So now I've talked to you about the history, and many of you know missions that have come recently. We have gone more and more, we've achieved more and more as we've explored space. Of course, from the point of view of India and ISRO, also, we have had many achievements all the way from Chandrayaan 1 and 2. Chandrayaan 3 is also upcoming. Then the Mangalyaan Mars mission. And we have many more missions, including Gaganyaan, which will be ISRO's human uh, moon mission. That's also upcoming. So let's talk about one more mission that is for your generation. It is the Artemis mission. So that's humanity's return to the moon. So how is Artemis different and what is its objective? So Artemis is also a NASA mission. So recently, as you know, once the space shuttle disasters happened, NASA turned over uh, it's what they did is they supported private industry. So since then, for the last 10 years, it's private industry that's been filling that hole. So all the way from uh, Jeff Bezos, Blue Origin, uh, Falcon X, these are all names of private missions that have now been going, and now they've successfully actually gone to the ISS and back. So NASA is trying to hand it over to private industry. So, what is the next mission that NASA is focusing on? It is called the Artemis mission. Okay, Artemis is the name of the moon, of the goddess that represents the moon. Okay, so Artemis, up till now, there have only been men on the moon, and that too only white men. So now NASA wants to bring in that diversity by landing the first woman and also the first colored man. That is one of the objectives, and they want to do it by 2024. So there will be new concepts in the Artemis mission, and NASA, now the Cold War is over. US has been collaborating with USSR for so many years, and in fact, in the space station, there are always astronauts and cosmonauts that live together side by side. So even here, NASA will be taking collaborations with commercial partners and other international partners to establish sustainable missions. And that's not the only objective. The main objective is also using moon as a halfway landing to make the leap to send astronauts to Mars. Okay, so what are the main objectives? The objective of discovery, again, creating a moon base and understanding how to live on Mars, the economic opportunity, and it's to inspire a new generation for space exploration. Okay, so Artemis is focused on lunar exploration, but the main objective is to build a halfway point where people can go. So there will be a base camp on the surface of the moon, which is called the Artemis Base Camp. But there will also be a space station called the Gateway that will be orbiting in lunar orbit. So these are the two major components, the base camp and the Gateway. And so the Gateway is where it will allow people to go to the next point, which is Mars. So the concept is called Moon to Mars. So, using the technology that's being developed during the Artemis space flights, NASA intends to launch a future crewed mission to Mars. Crewed mission means a human mission. So this is an intermediate step of building a habitable base camp, having astronauts on the moon, and building a space station from which you could go to Mars. So there are many technological objectives with this Artemis mission. As you can see, some of this have not been done before because we've never built a habitable space camp. And we've never used it as a jumping off point to go to Mars, which is much further off from moon is much closer, so the fuel, the time to go and come back, all this is much more doable. But Mars is a whole new challenge, and this will enable the scientists to build it step by step. So with that, uh, you can see, I want to reiterate that this is how space exploration started. But where are we now? Everything we used in our world is built on the backbones of this exploration, all the way from internet, GPS, satellite communications, satellite TV. Uh, you know, we use satellites for uh, remote sensing, for weather forecasting, for climate disasters. So I want you to just realize that everything in our world is built on the backs of this space exploration. And when the first cosmonauts like Yuri Gagarin went, and the first man on the moon like Buzz Aldrin and Neil Armstrong, they did not know what they were going to face. But because of their bravery, we are where we are now, where we have so many things at our fingertips because we just count on it. We count on GPS and Google Maps and internet and all these things at our fingertips that help us in our day to day life. But because of each mission, which dealt with all the problems that space would offer to them, like lack of atmosphere or zero gravity or cosmic wave particles. So, because each technology improved itself to deal with this, is where we are now. So, with that, I hope you all realize um how far we've come in space exploration, and uh, you're welcome to ask any questions.
Indeed. Thank you, Mila ma'am, for sharing such a wonderful presentation. And all the facts and data was very well put together to give the timeline look to the participants to understand, like you rightly said, that how long the humanity have taken a grand leap. If you talk about the first space mission to today's, and if you talk about India, it's still we are figuring it out, but the situation is vast much better than this because our dream mission Gaganyaan is about to take place. So
Right.
from we talk about for Yuri Gagarin to the Chandrayaan. So it's a huge difference we can see in the space science and technology. And yes, the GPS, the data, the satellite technology, the missions, and the missiles, everything have given a new ventures to the humanity altogether. So indeed, on this note, I will. Uh, Ask participants if they have anything to share, any doubt, questions. They are most welcome to drop in the chat box, and I will be highlighting those so that Mila ma'am can take those questions. So you are free to ask. Anything you would like to, even if you have some thing to comment on, so you are free to do that as well. Even ma'am,
Yeah.
many of the students participation are also are invited by NASA, even by the ISRO. uh,
Right. That's right.
Many
Because
of the scholar missions are there, the research based program in which they are asking students to participate in those. So if you can little give little glimpses of those, so that even if
yes, so both NASA and ISRO, as Prerna ma'am is saying, are very encouraging towards young students. So uh, ISRO, for example, recently launched its program. I mean, it's a relaunch, but every year they launch a program called Uvika, which is for students of class ninth, and you can apply to be part of the space camp with them. It's for a few days. So that's a way you can find out if you're in class ninth or you know more students who are, then you can be in that program and you can apply for it. But they also have ways to go and view the launches. Even schools can apply to go to Sri Harikota and view the launches. If not a launch, even you can view the museum and the public area and meet scientists. So that's a way to get involved in what ISRO has and see what ISRO has. So they are so you can do that. Now NASA also has internships, but most of those are available to US citizens. But besides the internships, they also have educational programs that they open up. They have what is called the NASA Micro Observatory, where it's a virtual telescope and you can apply for time to view something. They give you targets, you can view for time. So you can do things like that to get more involved also.
Indeed, and even like Mila ma'am explained, even STEM and space is also holding
Yeah.
several projects. You can also tell about that, ma'am.
Right.
Those
So
are
yeah.
really
So yeah, for all of you who are interested in space and your space enthusiasts, so there are organizations around India who are doing STEM outreach, and STEM and space is one of them. And we will also be holding summer camps, and we hold workshops. So just look up STEM and space, or look at the Facebook, and we will be holding summer camps. And through that, we try to bring to students what is there in space. Like we do all the way from how what are the parts of Chandrayaan to by making models. In fact, this time, as you might know, one of the big launches, I didn't talk about that because I didn't talk so much about modern missions, but one of the biggest missions that just went at the end of 2021 is the James Webb Space Telescope. And
yes.
James Webb Space Telescope is a huge improvement on Hubble Space Telescope, because of course with the years our technology gets better, so we can aim for bigger and better things. And now James Webb Space Telescope is trying to look further out into space than has ever been seen, further out in time. So what that means is, when the Big Bang happened and the universe started expanding, then the first light has now traveled to the furthest point, because it's like a balloon. It expanded, so it's at the furthest point. Now, how do you see things, light that is so far off? For that, James Webb Space Telescope has special telescope that operates in the infrared, that is super cooled, because otherwise infrared heat itself contributes infrared. And so James Webb Space Telescope has a 5-layer sun shield, and it's going to be at a very special location called the Lagrangian point. So with all these things, now James Webb Space Telescope, JWST as it's called in short, is aiming to look further out in space to more ancient times, and it will give us a bigger picture of what happened just after the Big Bang. So that's a mission that do keep your eyes out for, because it started taking its first snapshots now. And also
I
I want
think
to talk to you about
lot many
uh,
things are lot many things are on plate for the students who
yeah.
are interested in astronomy and space science
Right.
education.
And please, everybody follow Planetarium, because they themselves do so many programs, all the way from watching the sky and what's in the sky, how do you predict what's in the sky, and all major missions. So do follow them. So that's there are also two asteroid missions that have recently gone, called the Dart and the Lucy mission. And the Dart is very interesting because it's actually going to hit an asteroid and try to deflect it. Because many of you ask, when we do asteroid search campaign programs, that what happens, we're studying asteroids, but what happens if the asteroid is actually going to come close? Is it going to hit us? Is it going to impact Earth? is Earth going to, is it going to kill everyone? But the point is that we are also trying to find ways to deflect it so that it changes from its path a little bit and no longer harms Earth. So yes, there are very interesting new missions. So students do stay involved with, you can stay involved, watch STEM and Space, watch Nehru Planetarium, and participate in different webinars and hands-on projects that are being done.
So yes, and on this note, as we are celebrating the international first human space flight, so Nehru Planetarium is also holding online poster making competition. You can check more details on the Facebook page of Nehru Planetarium. So Russian centers has asked for the poster on the various listed themes. So you can give your handmade as well as your digital poster on any one of the theme, and you can post it on nehruplanetarium at gmail.com so that we can forward it to the Russian center. They have extended the date of receiving the entries. Now you can send it till 20th of the April. So probably after shortlisting, they will be finalizing and holding one exhibition based on your received entries, and the winners and participant will be getting uh, uh, attractive prizes and gifts from the Russian center. So this is something which I would like to share on this platform as well, because as we are celebrating this day, and as of now there
And
is no.
what is the theme again of that painting competition?
Ma'am, there are three themes: the future of the missions,
Okay.
today's and future of the mission, space exploration, and the first human space flight. So, whatever comes in
Okay.
your mind, you are free to use any medium. You can paint it, draw it, sketch, and you can also use the digital available. What do you call these illustration software, so you can give your entries in handmade as well as you can use your software to make to give your entry. So two entries one participant has to give. So really interesting way to yeah, draw and paint on the given themes.
Right. So
So, all right, as we can see, there is no comment in the chat box. So, we really hope that this webinar give you a little insight about the mission and how beautifully the humanity have evolved from the first through the today's recent missions, space missions and explorations. So, okay, we got one question with that. Did the spacecraft Challenger exploded in 73 seconds?
yeah, so as I mentioned, uh, in fact, people were, of course, watching it live on media, and basically it exploded right after launch because you know the like I said, the O-ring was something that was found later. Of course, when it exploded, nobody knew the reason, but it really exploded with all the astronauts on board. And unfortunately, because the first school teacher was traveling, there were even a lot of students watching live. So it exploded because the O-rings had a leak, and they let uh, you know that's what created the reason for it to burst into flames. So yes, just after launch, it exploded right away.
So these types of things happens, ma'am, generally because in last webinar, one of the participant was also commenting that when you know that this mission going to fail, so then why we are putting so much efforts and money into that? So
Yeah, so I
never
mean, you
know.
don't know for sure it will fail,
Yeah.
but basically, I mean, you're trying to make it work, and of course, so many missions did successfully launch. But it's the failures that give you the information of where things can go wrong, and you learn the lesson that you have to be very careful. And there was a 2 year investigation where each and every part was looked at. uh, and I was following the investigation at that time, and it was very hard because these parts are so small, and so it was very hard to actually figure out the true cause. And that's how you learn that even the smallest things might create a huge problem. And
Yes.
that's why part of the reason why after both these incidents, the space shuttle was grounded for 2 years, and they did not fly for 2 years in each of the accidents cases.
Yes, even in the part of Chandrayaan mission, because
Right.
Chandrayaan mission was into different phases, so the orbiter
Right.
did it work very good, and the images which we are getting it was very much fascinating and all. Though the lander got failed due to the soft
Yeah.
landing issue, but the orbiter did it work very greatly.
Right, and
So
that is what now, yeah. So some of these are where you're trying to make the technology work, and you're not fully successful at it. But that's how you learn what to do next time, because
yeah.
something didn't work. And also now Chandrayaan 3 is in fact going to improve on that, and it's going to aim for the lander and rover to happen. Yeah,
So like Yuri said, let's go and let's do.
right.
So,
So
many more things to do in the space exploration area. So
right.
with this, I think we'll take a leave and we'll wrap today's session uh,
So
with
thank you
good.
everyone for joining, and thank you again, Nehru Planetarium, for inviting me to be a part of this special day today.
Thank you, ma'am, for sharing such a wonderful presentation. And in future also, we will love to have such beautiful illustrated presentation on various new topics coming in the space exploration area, space fields.
Right.
So we'll love to
And
cover.
students, do stay interested and keep looking up. And you're welcome to join any programs with STEM and space and find out more hands-on about hands-on space.
Yeah.
Thank you again.
Thank you, everyone. Thank you for joining. Thank you, ma'am.